The first question I've gotten is when to use inheritance and when to use layering. Let me quickly explain what they are. Uh, inheritance is that we've already gone over. You derive from another class. You borrow the methods and fields and properties, the members of another class. So you get them for free when you make a new method. We haven't done that by ourselves fully yet. We did inherit from the game class when we made our engine class. So we got a lot of methods and things from XNA, but we haven't actually made our own class yet that we inherit from. However, we did make an image class, and then we made an image object inside our mouse class. This is called layering. That's when an object contains another object. So which one should you use? Should you use inheritance or layering? Well, the best way to do it is to check if the object is of that kind or if it has something of that kind. The question I usually ask is this a weapon or does this have a weapon? For example, a goblin is a monster, and therefore the goblin will inherit from the monster class. So this is the goblin class, this is the monster class, and they inherit. So this is the base class and the derived class. An animation is a kind of image, so they will inherit too. But a goblin has a club, and therefore I will use layering instead, and inside the goblin class I will create a field and instantiate a club object into that field. And that's what we did with the mouse. The mouse is the class that deals with the mouse, and in order to be able to show it, it has to have an image. So that's why we layered an image object into the mouse class. Good question to ask yourself. Is it or has it? Now the second question I've gotten is when should I use static and when should I instantiate something? For example, we made the mouse class static. So then when we went to the engine class, we never needed to put anything in the constructor. And we never needed to make a field for it. We just called the mouse class right away. Static, sorry, static classes, they exist without being instantiated. You call using the name of the class. We used the word mouse in the engine class when we were going to update it. And the rule of thumb is that if you only have one object of that type, then you can consider it being a static. Not always necessarily, but you could. And if you have many objects of the same type, then you of course have to make it instantiate them because you can't make them static. Now, that decision might not be so difficult to make, but there is another decision that is a bit more difficult, and that is if you have some members inside the class being static and some of them are not static. The rule of thumb here is when should you make some of them static? The rule of thumb is does this member belong to any particular instance? The reason why you need to ask this question is because they are separate. A static class, if you have a static method inside a class, then it can't call any of the instance methods. They're called static methods and instance methods, or static fields and instance fields, because they're simply not on the same names, the same area in memory. The static gets instantiated automatically behind the scenes when you start up the game, and the instance members, they get instantiated into an object packed up into memory when you declare it with a new keyword. So they're have nothing to do with each other. So the reason I asked this question is because they are separate, and the answer will provide the solution. Because let's go to the example. You remember Invaders, that when you were shooting the enemies, the fewer enemies were left, the faster they were going. So when you were programming the game, you needed to keep track of how many enemies were left on the screen. And by sticking to the design principle of encapsulation so that we don't have a lot of variables in the game engine class, we have them inside the classes, the smaller classes instead. Then the field amount, which should keep track on how many enemies are left, that should be in the enemy class, not in the engine class. But it doesn't belong to any particular one enemy, does it? Because if that enemy would die, then we wouldn't know how many were left, because then the amount variable would get it deleted. So that one is an excellent example of a variable that I would make static, because then it's accessible from any enemy. So when that enemy gets killed, and for example in the destructor, which you don't use so often, but this might be a time when you would use it, then in the destructor you would decrease the amount by 1, and then it gets decreased on the static, in the static memory section. So it gets decreased for all the enemies, not just the one that dies. In our project, let's say that we make box the position field in the box class static. That would be a bad design decision, because then they would all share the same position, which slot in memory, which means that all boxes would be drawn on top of each other. However, a better design decision is to make the texture field in the box class static. That means that there's only one copy of the reference to the image in memory. If you do like this, you could actually do the load graphics content method in the engine class. You could clean that one up, because right now in the engine we are actually making the texture and then we pass it as a reference to the box. And if you make it static inside the texture, inside the box, then all boxes we make would share the same texture, but there are some side effects to that too. Which one of those boxes should load the texture? We would have to have an if statement checking if some other box would already have made a texture or not, and then it doesn't create it if there already is one. The reason why I chose to not do this will become apparent in a little while, because we'll move on in this and you'll see. Now I did another thing. I used alpha blend and I used additive. So I used the same sprite batch twice to do different effects. And there is a few things you need to think about when you do stuff like this, because the sprite batch has an internal function, an internal method that is private. You can't see it. Flush is the method that takes everything that you have given it and sends it onto the hardware. And it needs to do that sooner or later for sure. But when it does that, it costs some processing power, because it needs to convert it from XNA to DirectX first and pass it to DirectX, and then DirectX will pass it on to the hardware. That's a problem that we'll have to live with, because XNA is a lot easier to program compared to DirectX. So one time that flush gets called is when we call sprite batch end, obviously, and when we changed from alpha blend to additive, then we needed to call end so that we could call begin and change to additive again, right? So here we called flush, but the funny thing is that if you change texture in between calling begin and calling end, when you change texture, it calls flush too. So let's say that you have 100 boxes, half of them say up and half of them say fragile. and every second box you draw says fragile, every second box you draw says um, up. That means that you change texture 100 times every draw loop. So internally, without you knowing it, flush would be called 100 times every time. So a good way to design it is that you first draw all boxes that say up, then you change texture and draw all the ones that say fragile, and then flush only gets called twice. Resetting sprite bind mode is what we did when we called begin after we called end, so that's the same thing. Something to think about. Now I get to the back to the texture. I want to show you the trick that I used. What you could do is you could store a texture in each box instance by when you call load graphics, then inside the load graphics method, inside the image class, you load the texture and put it into a field. That would mean that you have 50 box textures in memory. Pretty bad. So the option that we looked at earlier was to declare the texture variable. Since it was a field, it should be lowercase t there, I guess. If you declare that one as static, that means that they would all share the same object. So you would only have one image in memory. Much, much better. But the thing that I didn't like about it is that if I do want to change some boxes to say fragile instead, I can't, because if I change one of them to fragile, they all become fragile instead of some still saying up. So the solution I had was to load the image out in the engine, and then I pass in to texture, although in the engine it was called my texture, right? Pass in my texture from engine as a reference. That means that we only have one image for the up box in memory. We have lots of references to it in different box objects. And if I change some of those references to a second image in memory saying fragile, then I only have two images in memory, one saying up, one saying fragile, and then I just change references. So that's the solution I decided on. I hope that was reasonably clear. And by using these references, as I said before, then we can reuse my texture to load something else, like we did with the mouse cursor, because the texture is still referenced in the box instances, so that we don't lose that object. But if we do lose all the references because we delete all the objects, then C# will collect garbage, which means it will delete the object that contains the texture, the image of the box. A bit messy, but I think it was reasonably clear. Last thing, why do I split everything up on such small classes? You know, our mouse class was really small, for example. Well, I atomize code because it's easier to read. Not only is it easier to read for other people, it's easier for me to fix stuff, because I click through my folder tree until I find the file, and then when I open that file, the first thing I see is the thing I want to change, because it doesn't contain that much, and it gets easier to use as well. One thing that is also good, the smaller chunks you make, that means you can call small chunks of code, so you don't need to copy and paste any code. For example, let's say that you have code for moving a box around. If you have 3 boxes and you put the code for moving them around in the engine, then you would have to have the same code 3 times to move each box. So you write the code for moving the first box, copy it, and then paste it in 2 more times. So you move each box. By atomizing, then I don't need to copy and paste, because I only have one slice of code and I put it in the box class instead. That's why I refactor everything to a method, and I try to only have each method do one task, not more than one task, because then I can use that method several times, which is one of the reasons why I use verbs for method names, because a single verb describes the single action that it does. Uh, there are official naming conventions. I follow some of them, but I'm not sure I follow all of them. They're not mandatory, but they're good practice, so maybe you should check them out. Uh, and I always use descriptive names both for fields and properties and for methods, because for example, if you look at the engine, as you can see, we just write mouse dot initialize, mouse dot update, mouse dot draw. That's it. So once we have a lot of that, we'll have joystick dot draw, mouse dot draw, and so on. And box.draw and so on. So the engine will just be a long list of method calls, and if that list is clear, then it's very clear what your program is doing if you need to change something and have forgotten how it works, or if you hand it over to somebody else to help you work on it. So the engine class is definitely an overview. It instantiates some objects and then it calls each object. And that's why I name each method in each object the same as I do in XNA, because if I have update and draw on everything, then in update and draw in my engine, I just have a list of update calls and a list of draw calls. So it looks very clean and it's easy to understand. Not only do I atomize code into very small methods, I also atomize classes. As you can see, the image class doesn't do much. Just draws an image and that's it. So if I add if I'm going to add an animation, I'm not going to do that in the image class. I'm going to inherit from the image class and make a new class that derives called animation. And then I'll add animation code there. So I'll atomize classes too for the same reasons as I atomize methods. The rule of thumb I have is that I'm writing this as if it was a book. And if this were a book, would this be clear to the reader? That's the decision I need to make. That's why I try to keep engine as clear as possible, because that's the contents page of the book. And each chapter should only deal with one thing. Each paragraph, if you think of a chapter as a class, then each class should do one thing. Each paragraph, or if you want to call them a method, that's fine, should do one thing, one task. For example, the first paragraph describes the setting, and then the second paragraph describes the hero. Then I would have two methods, one to draw the background, one to draw the player character. I hope that helps. Some of these questions were asked to me, so that's why I added this. I love feedback. I'd love more of it, so do send feedback in. If needed, I'll update old videos as I get feedback. If possible, I'll add answers in later tutorials. Depends on how far I've gotten in shooting them. That's it for today.